Hi everyone. Today we'll be discussing the LeetCode problem of the day. Replace non-coprime numbers in array. So in this question, you are given an array, and in that, for any two adjacent numbers, if the numbers are coprime, then you can just replace both of the numbers by their LCM. Coprime in the sense, like both the numbers GCD will be greater than 1. So let's see it through an example. We have 6, 4, 3, 2, 7, 6, 2. So we'll just look at this array and see any two numbers that are adjacent which are coprime. So we can see that 7 and 2 are 6 and 2 are coprime, and their LCM will be 6. So we can replace these both numbers by 6. And the next adjacent numbers, these two are also coprime, and their LCM would be 12. Now these two numbers end up becoming coprime, so their LCM would be 12. So replace both of them by 12. Again, 12 and 2 are coprime since their GCD is greater than 1. So replace these two by 12. Now the final array is 12, 7 and 6. So no two adjacent numbers are coprime. So this is where we stop. So the output is 12, 7, 6. And in the second input, we have 2, 2, 1, 1, 3, 3, 3. Here also these two, both twos are coprime, so replace them with their LCM. And then 2 and 1, it's not a coprime because GCD of both of them is 1. And if we move, we can merge all these three because these three are coprimes, so replace it with 3. Again these three, replace it by 3. So the resultant will be 2, 1, 1, 3. We can't merge it further because all the adjacent numbers are not a coprime. Into the approach, we can just iterate the numbers from left to right and just do the operations on them until the GCD of the numbers is greater than 1. So first we have 6. So it's only a single number, so we don't do any operation. After that we have 4. So once you have 4, you check with this number whether you can do the operation or not. So you can, and the LCM is 12. So this becomes 12. After this, we don't have any other number, so it remains 12 itself. Then the next number is 3. So when you have 3 inserted, you can do the operation with this 3 and 12, and the result will be 12. Again, after that, you have 2, and 2 and 12 also have an operation together, and the resultant is again 12. After this, we add 7. So 7 gets added. So we can think of it like a stack. So we have a stack. Initially we have all these numbers merged and the result is 12. Then we have 7 added. After this, we have 6. So when we add 6, we'll see if we can merge it with the top number or not. So it's not a coprime, so we just simply add 6. Now at the end, when we want to add 2 in the stack, we'll see if we can merge it with the top number or not. So here GCD of 2 and 6 is greater than 1, so we can merge it. So what we do is we take out this number 6 and then we merge it with 2, and it becomes 6. Now again we repeat the process before inserting it. We check if 6 and the top number can be merged. So here the GCD is greater than 1, so we can't merge it. So we just simply put the 6 inside. After that we just exhausted our list. So whatever is in the stack, that is the final output, 12, 7 and 6. So let's start with the code. We'll first take a stack to just store the numbers and then perform the operation with the top number. So stack integer, and then just iterate on the numbers. Now once you have the number, you'll keep checking with the top of the stack whether you are able to perform the operation or not. That is, whether the GCD of this number and the top of the stack is greater than 1. And also while we have elements in the stack, so initially it is empty, right? Stack dot is empty. While stack is not empty, we just get the GCD of this number and the top of the stack. GCD of number and then stack dot peak. And once we get the GCD, if this GCD is greater than 1, that means they can be merged. So we'll just calculate the LCM. LCM equal to number into stack dot pop. Here we are removing the number divided by GCD. Also, the numbers can be up to 10 power 5. So when you just multiply both of them, they might overflow the integer range. So first you have to typecast it to long and then do the multiplication and division. And at the end, before assigning it back to int, we again have to typecast from long to int. Yeah. So once we have the LCM, now the number becomes LCM. We replace the number with LCM. That means we just merged this number with the top of the stack. And the else case, that when the GCD is not greater than 1, we just break. And after all of this, whatever is the top number, we just push it in the stack number. And then at the end, we have to return it in the list. So we'll just convert all of the numbers in the stack to a list. Answer while stack dot is empty. Answer dot add stack dot pop. And again, like we saw in the previous example, in the stack we have the answer something like this: 12, 7 and 6. So since for the stack it is first in last out, when we pop all these numbers, we get the array like this: 6, 7 and 12 in the reverse order basically. So we have to reverse this array and then return it. So for that, reverse answer and then return. Also, I have to just complete the GCD function. If b equal to 0, then just return a. Else return GCD of b comma a mod b. Okay, return answer. And submit. Yeah. And now coming to the time complexity, this is a bit tricky. So for time complexity, we can see that we are running a loop, and inside that we have another while loop where you're just iterating on the stack. So like suppose initially we have few numbers, 5 and then 8 and then 15, and you have a new number which is suppose 20. So for this 20 again, you will keep popping the top number and check if the GCD is greater than 1, and then if it's greater then you will merge it and repeat the same. But for any number in the stack, this number gets pushed into the stack one time, and it can be merged to the other number one time. So it can be pushed one time, it can be popped one time. So at max, each number have 2 operations. So in total, the total operations in the stack will be order of 2n. So which is same as order of n. But again in this stack, we are also doing a GCD, and GCD has time complexity order of log of the minimum value of a comma b. So the total complexity will be order of n into log of the max number in this array. So that is also up to 10 power 5. So it's n into log 10 power 5. And space complexity will be order of n, because in the worst case, if all the numbers are coprime, then the stack size will be equal to the length of the array. Yeah, I've also written the code in Python, so if anyone wants to check this out, yeah, hope it helps.